So beautiful people, let's continue with FE Civil Review Surveying Part 2. Problem number 1. Earthwork estimates for a highway project are summarized in the following table of end areas at stations 100 feet apart. The total earthwork volume in yards cubed between stations 20 and 24 is most nearly. So we have to calculate the volume between station 20 and 24 for this problem. There are a few ways you can solve this problem, but the fastest way is to use trapezoidal rule. You are familiar with using trapezoidal rule for calculating areas. You remember we calculate the area under a curve when we have distances. Let's do this. These are spaced at the same distance. In the formula, this distance is lowercase w. And then you have height 1, height 2, height 3, height n. And trapezoidal rule, what it does, it assumes this is a trapezoid. So instead of a curve, you have a straight line here. Now, in our case, we have to calculate the volume. Imagine instead of a height, we actually have, let's see if I can draw this in 3D somehow. This way, perfect. So we're gonna do the same thing. All right. So now I'm hoping you can see, wait a second, let me draw this up as well. Okay, so now instead of a height, we actually have areas spaced at a certain distance apart, w, lowercase w. In our case, we know that this lowercase w is actually 100 feet. And this is area 1, area 2, area 3, area 4, area 5, area 6. In our case, we have 1, 2, 3, 4, 5. So let's use trapezoidal rule. So the volume, it's going to be equal to W multiplied by A1 plus A5 in our case, divided by 2 plus A2 plus A3 plus A4. And going to the FE handbook, the only thing we did, we substituted instead of the height, we placed our areas. Great. Now we just can come back here and substitute. So W is 100 feet. And then A1, say this is A1, A2, A3, A4, and A5. So A1 is 405 plus A5 is 630 divided by 2 plus A2 is 576 plus A3 is 432 plus A4 is 378. And close the parentheses. The only thing you have to do now is calculate this using your calculator. And you should get a number of 190,350 feet cubed, because this is the volume. Okay, now the problem is asking to calculate the volume in yards cubed. So we have to transform this into yards. I think in the FE handbook, I'm not sure, units. Let's see if it gives you yard. So we're given here, in order to transform from meters to yard, you have to multiply by this. Or we have to, so you would have to do some other types of transformation. But one thing to remember, and it's not very tough, is that 1 yard is equal to 3 feet. Which means that if I have 1 cubic yard, that equals to this cubed, 3 cubed is 27 feet cubed. Okay, so coming back here, if I want to transform from feet cubed to yards cubed, I just have to divide this by 27. And this will result that the volume equals to, let's see, I get a value of 7,050 yards cubed. And looking at all the options here, it seems that B is the correct answer. Let's move on. For a particular site, the existing and the proposed ground profiles have been drawn to establish the following cross-sectional areas at stations spaced at 25 feet intervals. What is the volume in yards cubed of earthwork between station 204 and 205.50 using Simpson's rule? So in this problem, we are actually told to use Simpson's rule in order to calculate the volume. And the thought process is exactly the same. So I'm gonna add here, this is area number 1, 2, 3, 4, A5, A6, A7. Let's look at the Simpson's rule. I know Simpson's rule is under civil engineering, but it's all the way at the end. So I'm going to go to environmental and just scroll up a bit. And this is Simpson's rule. And we have W, which is the common interval. In our case, it's 25. Let's write this formula down the way it is, and then we're going to substitute. Or instead of height, we're going to put areas. Okay, so the volume is going to be equal to W multiplied. Let's come back here. We have H1, right, plus Hn. So we're going to say A1 plus our Hn is A7. And then next we have to add 2 times n minus 2. So when n is an odd number, that means we have to multiply all the areas that have an odd number with 2. Plus 2, and then we have A3 plus A5 plus, next we have to multiply with 4 all the areas that are even number. So if n is odd number minus 1, we're going to get an even number. So all the areas with an even number, we're going to multiply with 4. So that means we have A2 plus A4 plus A6. Close this parenthesis. Let's make this a square parenthesis equals. So now let's substitute. Oh, wait a minute. See, I always do this. I forget. You have to also divide by 3. So let's come back here. I'm going to say 1/3 multiplied by spacing and multiplied by everything. So let's say 1/3 multiplied by 25. And then area 1, 214.56 plus area 7, 233.23 plus 2 times, this is a square parenthesis, 2 times multiplied by A3 is 412.45 plus area 5, 325 45. Next, plus 4 times multiplied by area 2, 345.54, plus area 4, 334.78, and plus area 6, 276.45, close the round parentheses and the square parentheses, and this results the volume equals to. So all you have to do now is just use your calculator and make sure you add this correctly. And once you've done that, you should get a value of 47,922.25 feet cubed. Again, the problem is asking for the volume to be in yards cubed. So what we're going to do is divide by 27, or say 1 yard cubed equals to 27 feet cubed. Feet with feet go away. So now we have to divide by 27. And I'm going to get that the volume equals to 1774.9, which is approximately 1775 yards cubed. There you go. And it seems that D is the correct answer. Let's move on. Cut and fill areas are shown at 3 stations 50 feet apart. What is the total earthwork volume in yards cubed between stations 12 and 13? So the way we're going to approach this problem is, first we're going to calculate the cut volume, and then we're going to calculate the fill volume. And the way we're going to do that, again, we're going to use one of those Simpson's or trapezoidal rule formulas that we've used in our previous problems. We're going to use the trapezoidal rule, and we have a lowercase w multiplied by a1 plus a3 divided by 2 plus a2. So now we have w as 50 feet multiplied by a1, we have 230 plus a3, which is 30 divided by 2, plus a2, which is 45 square feet. Okay, and this is going to give you a value of 8,750 feet cubed. And now let's calculate the volume, or the fill volume. I'm going to have 50 multiplied by A1 is 176 plus A3 is 70 divided by 2 plus A2, which is 311. And calculating this, it's going to give you a value of 21,700 feet cubed. If we subtract these two, if we say F fill minus V fill minus V cut, this is going to be equal to 21,700 minus 8,750. And this is going to give us a volume of 12,950 cubic feet. So if you think about it, if you subtract the cut volume from the fill volume, you're still left with 12,950 cubic feet of volume that needs to be filled. So this is our correct answer. So this 12,950 cubic feet is the volume that needs to be filled. We have to also transform this into yards cubed. So we'll just divide this by 27, and this is going to give us a volume to be filled of 480 yards cubed. So the correct answer is D. We need to fill 480 cubic yards. Next problem. The table below shows differential leveling data using transit level. The starting station A is of known elevation. Find the elevation of station D. We've worked on a similar problem before, and I'm going to quickly go over this. So for those of you who have not seen my previous video, if I have station A and then station B somewhere here, and let's say this is the way the land goes. This is station B. Remember, we talked about the fact that this used to be done by two people. This is your instrument, and one person is here at the instrument and another person holds the rod at station A. We know our station A is the elevation 600 feet. And then this person holds the rod here. The person at the instrument makes a reading. This is the backside reading. And this reading gives you the vertical distance, which is this over here. And then this person from point A goes to point B and holds the instrument vertically. And another reading is done. This is called the foresight distance. And that is the distance over here at the station B. So now if you would like to find the elevation at station B, right, is equal to, imagine we have elevation at station A. So elevation at station A, we're going to add backside distance. And now we are at this point. We have this elevation. And if we subtract from this point this distance, which is foresight distance, we're going to get the elevation at station B. And then if you need to calculate elevation at station C, is going to be equal to elevation at station B plus the according backside distance minus according foresight distance. And moving forward again, elevation at station D is going to be equal to elevation at station C plus the according backside distance minus the according foresight distance. Since we are asked to calculate the elevation of station D, we don't need to calculate each separate elevation, B and C. What we can do is notice the pattern that happens. Notice how we are adding the backside distance and we are subtracting the foresight distance, which means that we can calculate this faster. We're going to do sum of backside distance is equal to 361 plus 214 plus 389 equals 964. And then we're also going to do sum of foresight distance equals to 534 plus 671 plus 444. And this is going to give you a value of 1649. Okay. And now if we start with the known elevation, or let's say elevation at station D is equal to, we're going to start with this known elevation, elevation at station A plus sum of backside distances minus sum of foresight distances equals. So this is 600 plus 964 minus 1649 equals, and this gives me a value of 540 93.15. And this is how you calculate directly the elevation at station D without calculating the elevation at each station. And you want to do that, especially on the exam, because you would like to make sure you spend less time or as little time as possible solving a problem like this. This means that the correct answer is D. And the final problem for today, the table below shows differential leveling data using transit level. The adjusted elevation of station D is most, of station C, because we don't have here. So this is going to be C instead of B. Not sure. There you go. So the adjusted elevation of station C is most nearly. So for solving this problem, we're first going to have to calculate the elevation at each station. And the way to do that, remember, we have to add the backside distance and we have to subtract the foreside distance. And so if we start with elevation at station B, it's going to be equal to elevation at station A plus backside distance minus foreside distance. Of course, the according backside distance and then foreside distance. From previous problem, remember, when we add the backside distance, all we get is the height of our instrument. So I'm going to put the value over here. We have 603.61. We get the height of the instrument. And then I subtract the foreside distance from this, which is going to give me the elevation at station B as 596.27 meters. And now I'm going to add the backside distance to this value, 596.27, 214 plus gives me a value of 598.41. So the height of the instrument is 598.41. And now I'm going to subtract the foreside distance to get the elevation at station C. And this is going to be equal to 588.7. Next, I'm going to add 389 to this number to get the height of the instrument again. So 588.7, 389 plus, I get a value of 592.59. And then subtracting this foreside distance, 844 minus gives me a value of 584.15. So what we did here, we went in circle and we are back now to elevation or to station A, and we got an elevation different than the one we started with. We started at 600 and we got at 584.15, which means that there is an error that occurred while calculating these elevations. So now we have to adjust the elevation at each station. In our case, we're only asked to calculate the adjusted elevation of station C. So this is how we're going to do. First, we're going to calculate the total error that occurs. And this is going to be equal to 600 minus 584.15. And this is going to give me an error of 15.85. Next, I'm going to calculate delta error, which means I'm going to get 15 5.85 and divided by 3 stations. I have A, B, and C. And this gives me a value of 5.283. And now in order to adjust all of these elevations, I'm going to come here at the one we have calculated, and I'm going to add to this elevation 1 time multiplied by delta. Station C gets plus 2 times multiplied by delta. And station A, in order to adjust it, we're going to multiply it by 3 times delta. So here, notice how if we add 3 times delta, we are actually adding this value here that we're missing. So we're going to end up station A, we adjusted it, it's going to be back to 100 to 600. It's going to be back to 600 meters. Now at C, we're going to have elevation station C adjusted equals to elevation at station C that we have calculated plus 2 times delta. This equals to, we have 588.7 plus 2 times multiplied by 5.283. Let's write this value here. We're going to get an adjusted elevation at station C of 599 267 meters. And the same way, you go ahead here and calculate the adjusted elevation at station B, if required. Looking at the answers, 599.27 is option B, the correct answer. And that is it for today. We went over 5 problems. I hope I have clarified some things for you. If you have any questions, please leave them in the comment section below. Don't forget to like and subscribe if you found this video helpful. Have fun working on these FE problems, and I will see you next week.